Okay, so we are recording now. So
Okay.
hi everyone, thanks for joining today's seminar series organized by the Empathic Computing Laboratory. I'm your host Pai, and our guest speaker for today is Shunichi Kasahara. He's currently a researcher at the Sony Computer Science Laboratories, and his research interest is mainly about control and extension of the human perception. So the title of his talk is Superception, Engineering the Sense of Self, which is a research framework that makes it possible to expand, transform, and engineer human perception and cognition. So the talk will be roughly an hour, and then later on we will have about 30 minutes for a brief Q&A session. And for your information, this whole talk is recorded and will be uploaded in the future on our lab website, so be sure to keep an eye on that. Without further ado, over to you, Kasahara-san.
Okay. Thank you for the great introduction, Pai-san. And then thank you for the inviting me such the very nice opportunity. It's very honor for me. Thank you so much. So nice to meet you. My name is Shunichi Kasahara. So I'm okay. So let me start my talk. So okay. So somehow my face is so I should slide this. Okay. So thank you for again. Then I'm a researcher at Sony Computer Science Laboratory, and then mainly I'm working on for the three activities. The one is the very basic, but basic or applied the cognitive and perception research with interactive technologies, including like VR, AR, or some other technology. And also, sometimes I'm doing some research exhibition based on my researches. And also, of course, I'm in a company, so I'm doing the more deploying research activities for how we can transfer our technology into the industry or a product or something. So I'm mainly working on that kind of the activities. And then today I will mainly talk about the top two the topics like research and also exhibition things. And also then who I am. So I am right now I'm a researcher at Sony Computer Science Laboratory, and also at the same time I am the project assistant professor in Todai in the Elato Inami Design project, which is also very related to my research interest. And then from before that, I was in the I got a PhD at the Tokyo University. Then my supervisor was Lekimoto professor. Maybe many of you will know about his the project. Oh, sorry about that. And then also actually before jumping into this kind of the academia, I was in the industry, R&D, research and development. So I was actually in the engineer and research engineer and Sony corporate headquarters. And at that time, I also have a chance to go to the research kind of the research abroad in the MIT Media. It was only 6 months, but I had a kind of chance to work with the fluid interfaces and also tangible media group and the MIT Media. Right. So I'm working on the Sony Computer Science Laboratory. And then this is actually my broader question and my broader the research interest of my activities. Then what is me? What is myself? Because I think that this is a more very vague but more conceptual the key sentence of my research activities. So the sense of self is actually very quite ambiguous, and then how we can leverage that kind of ambiguity for enhancing or augmenting myself. That is actually the rooted my sorry, I'm changing it. Okay. This is rooted my interest. All right. So let me start my the previous research, which led me to that kind of the research or interest. So this is actually my PhD work and the Professor Lekimoto's the supervisor. So that was called the product jacking head. So this is like a very immersive visual telepresence system using head-mounted the omnidirectional the camera system. So let me play the videos. So this, when you wear it, we can capture the kind of full surround 360 video around our head. And then by transmitting this video, so the key idea is kind of sharing that kind of immersive visual with others. But as you may notice, that kind of the immersive visual always have some kind of emotion because it's mounted in the head. So imagine that we are in seeing the head first-person video from these guys. You know, that's a huge motion and then it's not like what we want. So this is the too many not rotation the motion. So actually I developed some like motion compensation technology using the image stabilization. So it's in real time we can compensate the head motion from the video image. So the result is something like this. So for instance, imagine that you're seeing what he is doing from his point of view, but actually the visual rotation is compensated. So something like this. So in this condition, we can even more look around as we want. Right. Something like this. So using this technology, for instance, we can do something like we say it's a jack in, so we can jack into the person who are running in truck, or we can or we can jump into the head who is flying on the something like this, or we can also jump into the head in the people is flying on the ski or something like this. So it's a very kind of immersive experience that using the head-mount display, we can experience the first-person visual, the scene, something like this. Right. So originally the idea is something like a telepresence. So you imagine that you're in your home, like in the COVID situation right now. So we are in the home or kind of on the room, but we can jump into another guy's head, and then looking around the scenery. But actually, I actually found a very interesting phenomena or sensation when we trying the things when we are demoing something. This is it. I will show you the demo. So this guy is wearing head-mount display, and then actually this is me. And then I am wearing this is the head-mount jacking head, like a 360 video system. And this guy is looking around from my point of view. And then when we actually very interesting, the sensation happens when we're doing something like this. So as you can see, this is me, and then this is the guy. So this is me, and this guy is this guy is looking at from my point of view, right? And then we are in shaking hand. But think in this moment, he feels very interesting, the feeling that I am shaking myself. Because imagine that the suits guy is looking while watching the world from my point of view and the shaking hand. So it's like a symmetry. So the motion and body posture is actually synchronized in the completely, and then somehow from his head-mount display, he is watching my body from my point of view, but still he feels, oh, this is my body, and this is like I am shaking himself. I am shaking myself from my body. Right. This is still a little confusing, but this is very interesting because I was thinking like a sense of self is stable. So because we are living in our body, then we believe that. I believe that my sensation of myself is very stable and then like a rigid. But from this point of view, it's not true. I found the sense of self is actually very ambiguous. So the idea is, or maybe we can leverage this kind of the ambiguity to enhance or augment our sense of self. So I started to explore more about based on this concept. Then I started to the project, the Superception. The Superception is kind of the mixed word between the super and the perception. The idea is like by leveraging those kind of perceptual ambiguity, we can expand or augment our sense of self and also the perception and cognition by myself by technology. Right. Then after doing the Hetman Jacqueline Head project, we did another project, more complicated version of the view sharing. This called the Parallelize. So as you can see, the 4-person is wearing Hetman display. This is actually smartphone based, the Hetman display, and you can see the 4-split view behind the screen. This is actually what they are watching. This is the 4 view is the same time we can see. Sorry. Wait. Sorry. Let me. Okay. All right. So sorry. Something happened. Okay. Right. So this is very simple setup. So by using the video transmission over the network, we can share the first-person view from each other. So this is something like they are watching in real time. So when we trying to shake hands, this is very weird sensation, something like this. So 1 of 4 is myself, but 3 of 4 is the other person's point of view. And then using that visual situation, we did very interesting activities, tag game. So this is something like this. So we set up some maze, something like this. Then people started to chase each other, something like this. So from outside, it looks like a usual tag game, but actually what they're watching is more complicated, something like this. So the people, we can see all person's first person in the same time. So it means like the people feels like, oh, I found myself in other guy's view, something, or this guy is confusing because I can see myself from other person's view, but I cannot where it's come from or something like this. So from the beginning, it's very complicated. So I thought maybe, oh, this is too early for a human being. But in the end, gradually they get some idea to how to use those kind of view sharing, and then eventually some people get ability to escape very efficiently or find myself from other person's view. So I actually analyzed how they react to those kinds of visual situations. Then I found they have a lot of very interesting ability to find myself, and also interestingly, they estimate the spatial coordination between the other person and also myself, and then they can escape very efficiently. So actually, we use this technology for sports festival, the entertainment. So this is kind of crazy, but this is I have to say, learning with the paralyzed. So the 4-person is racing each other with this visual situation, then with track. But the interesting, the interesting thing is happened when we do very, interesting is happened when we shuffle the layout. So I will show you some example. So this is the people is running in the track. 1, 2, 3, 4. You can see 1, 2, 3. So they're, but this person is suddenly misunderstand the race. So I will explain what happened. So when we see the screen, that you see the shuffle. So shuffle. So in the moment of shuffle, the layout of the full screen is actually shuffled. So people, for instance, before shuffle, the people understand, oh, maybe I am a top left view and then I can just concentrate that view. But in the moment of shuffle, the layout of the mix up, and then we lost myself. So in that sense, this people is suddenly lose herself, and they misunderstand the own perspective, then misunderstand the other perspective, other myself, and then started to go into another way. This is very interesting the phenomena, but this is also the sign of the fragile or how ambiguity of our perspective is. So this is interesting because this is me, it is me, or this is me. The notion of this is very fragile. And also, I try to another interesting trial with memory drawing the activities. The memory drawing is like how to say, when you ask to write a giraffe with own visual memory, own memory, this is very quite difficult because when giraffe has a lot of the function features or characteristics, then we cannot remember all of them. But when we do it in the parallel situation, what happens? So I actually do this drawing activities with parallel. I asked them to write the giraffe, but with own memory plus parallel situation. Then, as you can see, the result is very interesting because they end up to write down very interesting, very similar output of the giraffe. Something like this. But the one thing I found very interesting is, for instance, actually, the correct answer of giraffe is something like this. Then this is an example of the outcome of the workshop from the, how to say, this is like drawn by the adult person. Then you can see the top four is the giraffe has the ear, and then bottom four the giraffe has a horn, but no ear, right? Then the answer is here. Giraffe has a horn and ear both, but somehow the four person each other complement each other, then convince each other. Then maybe this is the giraffe, and then maybe this is giraffe, and then they end up like a slightly different outcome. But this is interesting because they actually compensate each other in real time. So this is the graphical the indication of where did they watching in the drawing with eye tracking. So the color represents where they were looking at, and then for instance the P1 participant 1 is the pink is watching themselves, watching on view, but the other color is like means the watching other drawings, and then they, as we can see, they compensate each other. But the interesting thing is after such kind of drawing activities, then I asked them, did you watch, or did you look at the other guy watching? Then they said no. I actually watching. They usually say, oh no, we mainly focus on my drawings. But then the eye tracking says they are kind of cheating each other. Then output very similar outcome. So this is also interesting because using that kind of interventional technology, we can intervene the notion of the this is what I do, something like that. So from this point of view, so I started to think about what itself. So then what itself in the philosophy, the academic philosophy, the Sion Gallagher explaining about the two components actually. The one is a narrative self. Narrative self is more like based on the self notion of based on stories or history, or or something like a story other tells, or photo tells, or video, or something like that. So it's kind of a story constructive themselves. The another more important for me is the minimal self. The minimal self is like a very minimal factor of this is like happening in real time. In this is the I who is experiencing now here. So because of the minimal self is very in real time interactive things. So minimal self is also composed the two minimal factors. One is self ownership, and also another one is self agency. So the self ownership is like a sense of this is my body, and then the self agency is the sense that I am initiator of this action. So I started to think about like how we can engineering or control that's kind of the minimal self factors. So in this very short notion, the what itself in real time is construct from this is my motion, this is my action, and also this is my body. So then I will show the two projects based on these notions. One is this is my body. So because of this is my, when we think about like a body, we have a two channel of the understanding myself. The one is very intrinsic reflection of self. Like we have some like inertial sense of body. And also extrinsic reflection of self is like a visual or sound or something. So it's like a reflection of my body itself, then perceive the visual or sound or something. So this is very, so maybe many of you know about this thing. This is called Lava-Hand illusion. So when you provide some like a synchronous haptic sensation to real body and also the rubber hand body, so this woman is watching only the rubber hand, but having a tactile sensation because of the other guy, the hands, they looking at something like this. So it's a haptic sensation is synchronized. So then gradually this woman believes that this rubber hand is her hand itself. And then in the end of the experiment, as you can see, after that, maybe then after that, suddenly the rubber hand is hit by the hammer or something, then she is very surprised. So even she knows that this is not my body, but she surprised because in intrinsic way, she believes that she feels like this is my body. So when we think about this phenomena in the virtual world, as you know, the kind of virtual reality is making possible to produce some kind of sensation in real time in virtual environment. So I actually did this project I think 3 years ago. It's called malleable embodiment. So sorry. So this is very the simple the virtual avatar using the virtual head mount display. So the idea is very simple. So motion capture the full body motion capture is capturing the full body motion, and then they're showing it instead of the real body, but we are watching the virtual body, something like this, from the first person view. Then but instead of the providing real-time true value of the body, we actually, so this is a video, and then somehow he feels how his body is lighter than usual. Then this is actually the trick behind it is not, instead of the providing real-time true value of the motion, but we actually anticipate the motion, body motion, and instead of the real-time true value, we show some kind of future estimated body posture instead of real time. Then he feels, oh, my body is get lighter or something. So we didn't do anything about physical, but only changing the visual, visual representation of the virtual body. He feels his body is lighter. Right. So this is the indication. This is an example of the spatial temporal deformation. Then you can see the yellow is real time, the original motion, and then pink is slightly time shifted towards future, anticipated motion. Then they feel, oh, my body gets lighter. So as you can imagine that, so when we intentionally put some delay, they feel my body get heavier, something like this. So he said like, oh, I'm a bit hungover or something. Right. The interesting thing is that we can control that parameter of the 0 millisecond is like a no intervention, time temporal intervention. Then plus and minus is like a anticipate or providing the delay. And then you can see that when you put like a plus, the future estimation, they feel like a joy or young or like a more lightweight. Then when we put like a delay or slightly the time shifted towards the past, they feel like, oh, maybe my body is a little bit exhausting or heavy or something. But very interesting, the aspect of this, the phenomena is we can control this parameter. So this guy is doing the virtual environment. Then I can control the parameter of the parametric control by I can put like a slightly faster or slightly slower. Then he feels, oh, my body get kind of heavier or my body get lighter, without knowing actual the intervention. But they feel actual the sense of change. So I think this is a very interesting way of intervening human perception, more parametric way. So from this notion, when we think about like an interface, of course, the interface is for interacting with the outside of my body. But by using this notion, we actually control by myself, own sensation by myself by parametric control. So it's like when we have a hangover with alcohol, but then we can control the sense of my body by intervening such kind of technology. So because the sense of self is, previously I was thinking of the sense of self is we cannot access the sense of self, but I found we can actually access these kind of sense because using that kind of the visual or the visual intervention using virtual reality something. Right. And also I did another project to intervene the sense of self, of the sense of my body using the shadow. So this is another project using the shadow. But you know, the shadow is very very most simple existence of the projection on myself. So we know the shadow is the reflection of myself, but what if the shadow itself is transformed? So actually, so I will show the video, short video. So this is called fragment shadow. This is the projection mapping system to provide the real time, the physical shadow control. So this is not like this shadow. But as you can see, the people is standing in front of the screen and then watching their shadow. But this shadow is the physical shadow. It's not a camera captured shadow. So doing some comprehensive spatial geometry and color calibration, we can provide like a real time, like a control of the shadow, something like this. So you can see that this shadow is actually physical phenomena, not like a digital projection, but you see the shadow is something like a texture, something like this, or shadow is transforming something like this. So this is because like a multiple projector is projecting one screen, and then if we step into that projection, the areas, the shadow itself is fragmented or transformed in optical way. So that we see like our physical, real-time physical, the shadow is transformed or fragmented, something like this. And then this provides actually very strong sensation of the change of myself, because this is providing the real-time, no zero latency, and the very ultimate resolution, because this is a physical. So we feel like oh, my body is like immersive in the graphics, something like this, for instance, or something like this. So okay, so I will stop. So the basic idea is like sorry, this is more technical thing, so I will skip later. By calculating like the color and also the spatial, the geometry on the screen, we can construct very special projection, the screen projection, the environment, something like this. So when you step into the area, you see the shadow itself. It's changed. Oh. And then the interesting moment of using, interesting moment of the fragment shadow is people somehow started to dance or doing some yoga or something like this. People somehow, we didn't instruct to doing so, but people somehow started to move their body, something like this. So because of the shadow, it's very, how to say, intuitive, and also the very reflection in real time. So they feel like a change of the own body sensation. So, and then this woman is also interesting. So she feels like, oh, this is my body, like a shadow or something, and then she's very curious about. But as you can see, so people somehow started to dance or moving their body. And the interesting thing is that when you provide the different visual the effect in the fragment shadow, they change the way of moving their body. So this is like an interesting the aspect of the fragment shadow to providing the change of self. All right. Okay. So then let me move on to that one more aspect of that. This is my action. So this is my action. So okay. So I will show you that one project which is done with Junishita and Tsukuba University. So this is called this is the project Wired Muscle. So maybe some of you know about this test. It's called pen drop test. So when you trying to capture the pen, something like this. It's very hard to capture. So maybe please try to yourself in other guys. So the people can drop the pen and the other guy is trying to catch the pen. But it's impossible. But when you put something like a very weird gear, we can capture, we can grab the pen, something like this, right? So I will explain a bit more. So when we usually doing the pen drop test, we have a visual reaction time, latency. So usually when you want to grab the pen, we have to perceive the visual situation, and then the cognitive process understand that, oh, the pen is going to drop. And then motor plan, we have to came up the motor plan to grab the pen. And then finally the muscle is actuated by the signal, and then hand moves to catch the pen. But this process takes over more than 200 milliseconds. And then this is not enough. This is not enough fast to catch the pen. But what we did in last video is actually bypass the phenomenon. So using the EMG, electromyography, we can capture the muscle, the activity of the pen release. And then using electromuscular stimulation, using like a EMS, we can the force to move the hand to catch the pen. So we can capture the pen, right? So let me play the video again, right? Sorry. Okay. So first of all, the EMG found the time of the release, and then after that, the system bypass, and then EMS, we put EMS stimulation to move the finger to capture the pen. And this is actually very fast, much faster than usual visual reaction time. It's almost like a 60 milliseconds. And then after that, our voluntary motion, all motion is coming after, but it's already done. Right. Okay, and then we actually doing the execution using that phenomena and over the many times in SIGGRAPH or other conference. So this is without the wide muscle. So she could not capture the pen. Then after the turning on, then as you can see, she could grab the pen very easily. Something like this. And then at first we found, oh, this is interesting. And then this is like driving the human muscle by the computer, bypassing human processing. But interesting phenomena, interesting findings happens because even we actuate their finger or their muscle, they say, oh, they grab the pen. I grab the pen, they say. But the actual physical phenomena is not true. So we are actuating their hand to capture the pen. So it's not their action, but somehow they feel, oh, this is my action. So I think this is interesting because even computer intervene their motion, but still they have a sense of agency for their motions, right? So then to investigate this phenomena, we started to more investigation to understand switch phenomena. Because of the too early EMS, we don't have a sense of agency. We know, oh, EMS doing this action. So we hypothesize that there are some time window that even our finger or our motion is accelerated by machine or computer, but still we feel this is my action. So we did a very simple the psychophysical experiment use very simple setup, something like a tapping task. And then this is very simple. Sorry, very simple. When you see some visual mark, then please tap the screen. But in the same time, the EMS also actuates your finger. And then later on, we evaluate do you feel this is my action or not. Then we actually investigate the psychophysical the curve. And then we found even we accelerate the motion in average 80 milliseconds, but still they strongly feel that that was all motion. And then using this time window, even my finger is actuated, but still we can feel like, oh, this is my action. And then using this, the phenomena, we can do something like this. For instance, like a speed photography. So when you're trying to capture the very fast flying object, we cannot capture because our visual reaction time is not fast. But when you integrate the system to actuate your finger, something like this, and then something like this. So this is your finger is actuated by shoot the photo. Then we put some task detection in the machine, and then using that integration, we can capture the perfect photograph of something like this. But this is actually accelerated by the EMS, but still we feel, oh, this is my photo, right? Okay. So this is called preemptive action. Right. So, but still we still have some like a more question about why we feel this is my action. So there are some hypotheses about model of the sense of agency is comparator model and also the hierarchical model, more the cognitive judgment of the sense of agency. So we apply the idea to more complex choice tasks. It's the stroke test. So as you can see, when you instructed to the touch red color in this screen, the correct answer is left, but the text itself is colored in opposite way. So it's induced like interference of the cognitive load. And then people sometimes mistake or sometimes get delayed to answer. And then the key question is that we can intervene. That's the cognitive task. And for instance, like as you can see, maybe you can see the video. So something like this. So this is very difficult. Okay, let's play again. It's very fast. So we have to. So first of all, we are instructed to choose left text, and then we have to answer left because the text left is left, but the color is interference. And then using this paradigm, we put like we have to the 200 choice task, and at the same time, EMS also intervene that action. It means like something like this. So we put EMS in both hands. And then sometimes the EMS provides the assistive motion, like a forced to choice correct answer. And then sometimes the EMS provides adversarial the action. It means like a EMS provide force failure action for the action. And then it means this creates very interesting the matrix of the human response and machine response, because in this experiment, human response will correct or incorrect. But also the EMS actually the human to correct and incorrect. So it means like even for instance, even human providing the correct answer, but sometimes EMS provides the false failure, or even people provide incorrect response, but sometimes EMS provide false success, the action. And then we investigate how they feel in such the situation, right? So situation is something like this. So the situation can be categorized very roughly two categories. One is the human and machine, human computer congruent action. It means like a human is touching left hand, also EMS providing left hand actuation. And then the condition is human computer incongruent condition. It means like the even people is trying to touch the left hand, but EMS provide left hand, but EMS provide right hand action, something like this. And then after, then each trial they are instructed to provide like a sense of agency in the questionnaire 1 to 7. And then the roughly say I'm showing some results. The roughly say interesting thing is one of the interesting thing is like even in the very complex task, we can clearly distinguish difference between I and the computer when we doing different motions. It means like when you want to touch left and then even EMS provide light, we found, oh, this is not my motion. So we can get like a very clear discrimination of between I did and I did not. So this is very interesting because like even we are doing the match for 200 the selection task. So motor signal is having a very critical cue to understand the self motion. So it means like if we have an incongruent motion, incongruent situation, like I am touching left hand, right hand, the EMS provide left hand. It provides motor, it provides error in motor level, and then it provides very clear distinguish between I did and I did not. But more interesting, the finding is here. When human and less machine provide same action, then how they feel. And then this is the graph of the vertical means like the sense of agency score, and then the horizontal axis it means like the temporal axis like EMS is faster or human is faster. It's showing that the green the blue one is showing like EMS and also the human has a correct answer. And then red block showing EMS and human providing incorrect answer. And then as you can see, when the answer was correct, the people more likely to attribute the success to themselves or human. And then if the answer was incorrect, they're more likely to blame the failure to the machine, right? So it's in short term, like a success is myself, success is by myself. The failure is more likely to buy computer. But even it's always it's always happen in same way, but they perceive the bias based on the outcome of the actions. Right. So this is something summarize of this thing. Right. So this means like when we think about the integration with the machine and the computer, our human actually have some like a bias for the action outcome based on the result. So I think this provides very interesting implication for the human and machine integration. Right. And then I'd like to briefly show about another project with collaboration with Tokyo University. And then this is the implicit force intervention in tug of war. You know, tug of war is like a very simple the physical game. So as you can see, this is the two guys is kind of pulling each other, something like this. And then you see the light guy is winning, and then after that, but you see actually this game is actually controlled by outside, as you can see. So the behind the guy is actually control some motion, right? But the two people in action didn't notice this intervention, right? So this is called the tight game. So the behind trick is like the motor is in outside behind the system. So the two motor is actually the towing each other, and then also they have some force sensor inside the tug, something like this. Then we actually control how we control the force assistant implicit way. So I don't mention about more brief. I don't go into detail, but using by leveraging like the pass, but by leveraging like the sensitivity of the external force, we can control the ratio of the force assistant for two guys. And then using this thing, we can, for instance, we can provide very implicit the force assistant. Even this situation, they will not notice the force intervention, something like this. So even that this guy is that's pulling very much, something like this. Right. But the idea is something like how we can intervene the human interaction in implicit way and without losing sense of agency. This is the more core the idea of this thing. Right. Right. So and then even it's like still the random idea of the Superception project, but this is very rooted in the two notions. This is my body and this is my action. And then when we think about like engineering of self, even because of the computer technology can provide more faster, more accurate, more the reliable the recognition, and also the provide the decision making. Actually, instead of our brain, the computer also provides some like action or decision. So I think right now, the computer-human integration having a very interesting three factors. The input, the sensory input also can be done in computer technology, and also the two is a human-computer integration in motion way. But this is like what I did in the EMS. Then after that, we can provide integrated action with own motion and also provided by computer, right? But I think more important the aspect of this the computer-human integration is like the sense of self. So because of we have some sensitivity or we have a sense judgment of the self and not self. And this is actually not binary. It's more like very the blurred between the blurred boundary between the self and the not self. And then by understanding that error, we can understand even we have an integrated action, we can feel like a self-attribution to integrated action. This is, I think, very important. Which means like because the human-computer integration provides like exceed our human abilities. So beyond own the abilities, or beyond own action sensitivity, or beyond the speed. But still, it's important that still we can feel this is my action, or this is my body, or something. So I think that designing that's the loop. Then the final loop is self-attribution. How we can provide self-attribution to integrated action. It's, I think, very important aspect for the human-computer integration. Right. So, it's like a studying of the Superception project, but I'm thinking about something like this today, and then still I'm doing another project which did not publish yet, so I cannot talk today. But if you have some interest, please let me know. Then I can share the current or ongoing project if you want. Also, by the way, also CSL has the internship program actually, and then because of the COVID-19 situation, we are now slightly kind of temporarily stopping the internship program. But I guess in 1 or 2 months, maybe we will resume that internship program. So if we have some interest in working on the CSL, please contact me and then we can talk something. Okay, so this is my end of my talk, and thank you for your attention.
Great. Thank you very much for your interesting presentation, Kasahara-san. So we are now open to questions. For anyone who wants to ask anything, please just raise your hands on the participant list. I'll just call you out and I'll unmute you to ask a question. Otherwise, if you're feeling shy, you could just type your question into the group chat and I'll read it out for Kasahara to answer them. So is there any questions from anybody? Well, maybe I'll start off first for questions. So there are several, as I understand, several students in our lab who are actually working on 360 videos actually. So there could be some interest in your Jack in Head project, which is one of the first ones that you worked on. I was just wondering that the prototype that you built for Jack in Head, it's obviously different from commercially available 360 cameras. Can you tell us like what's the difference, or how's the cost of it, or is it even a prototype that's being worked on by Sony? Anything like this? Can you share with us the details of this project?
Okay. So right now, so actually, it's the right now commercial available 360 camera is like a compound, like one form factor, and then something like a liquid shooter or something like a one thing. But because I want to provide like a true first person, I think I level the visual. So I actually, this is how to say, we actually develop the new hardware, but it's not like a hard develop from the scratch. But actually, we maybe you can see this video, right? Okay, so I think we can see right. So we can see some module down here, or maybe this is built. Let me see. Here, that's so. Oh, sorry. I want to control the video. Okay. Oh, sorry. Oh, I can control. Okay. All right. So you see now that camera is how to say, the customized version of the action camera. So we actually, how to say, they separates the component and then provides new lens to the image sensor. So it's kind of the very customized version of the consumer product. But not unfortunately, it's not commercially available right now. But still, the deploying project is going inside the Sony CSL. So hopefully in near future, we can provide the commercial available one.
Yeah, no, I think it's a great thing actually, because like you said, is you can actually provide someone with true first person view as opposed to, you know, like if you put it up here, it's just going to be this huge distance from your eyes.
Yeah.
But this actually lets you be in first person view, which I think is quite interesting. And you also had custom software as well, right, for the stabilization and everything. Are these
that's
somewhat open source, or are they right now just mainly or
no,
are they
it's
in
not.
paper?
It's not commercial open source, but I put almost a basic idea into the paper. It's I think it's an IEEE TV CZ paper. I will paste some URL later, but basically this is the all computer vision algorithm using like a GPU accelerated OpenCV based on. So I built the custom software to providing stabilize. So it's kind of the first of all, we stitch the several images into the full the equirectangular like through the 360 video, and then to process the image stabilization. Yeah, in real time.
Nice.
Yeah.
All right. Any questions from anybody else?
I have a question.
Yes, Chloe.
Um, I'm interested in changing people's perceptions through like subtle intervention. So this is your work is very like the tug of war is actually more subtle. Would this also what part of superception would this I don't know, intervention have? I don't know if my
Sorry, can you rephrase? Can
yeah.
you say again? I want to understand your question.
How would the unnoticeable change in perception uh, would this still be a part of superception?
Yes. Thank you. Thank you for question. Great question. So yes. So and yeah, that's great. Actually, this is very fundamental question of the what is the perception and why is the subtle intervention of the perception. Then because of I was thinking about the superception. The first of all, then this is like a or maybe we can imagine that very how to say explicit way of the intervention. But when we think about like a computer interaction with the provide how to say computer interaction, the explicit channel is kind of the more how to say almost overall from our daily life. So we have because we have some like a lot of the mobile or a computer interface or something like this, or daily life communication. We have already all of our the daily emotional activities based on having like a lot of channel with explicit channel. But when we want to provide how to say the expanding or human perception or cognition, I think the more implicit or unconscious level is more. I believe we have a lot of possibility or potential by leveraging such kind of subtle channel. That's why I'm very focused on the subtle channel of the intervention. I hope this is answer for your question.
Thank you.
Great. Any more questions? So I'll ask one about the paralyze. So I was fortunate enough to try paralyze, I think about maybe 3 years ago. And
Thank you.
like you described, the first time you tried on, there's a lot of information going on. But then after a while, you learn to leverage the other information that you get to achieve the tasks that you need to do. So my just a simple question is, from the workshops that you run so far, what kind of feedback do you get regarding this training period for people to get used to such a view for them? Like, is it different depending on like, have you any idea of the variables that's involved for people to get used to such a different training period? Because this is obviously not normal for humans to view the world, right? You're viewing from different perspective to learn a task. So do you have anything to say about like the training period regarding using something like this?
Right. It's sorry. Let me clarify the question. Like, is how to say in terms of scenario of some training or
yeah, I suppose like given a task, there's gonna be a time where you need to learn how to use something, because like the first time when I use it, I will pretty much just look at my view because I'm used to my view because that's how I normally see the world. But then you start to realize in time that when you need to achieve a task like catching someone or even drawing something, you can get a lot of additional information by looking at the additional windows. And then, it takes some time to understand all this information, and then it parallel with your own vision. So there is some sort of like learning or training involved until you get to the point where you're actually very efficient with such a system. Have you any idea about this training period for efficiency?
Okay. Thank you so much. Thank you. Yeah, that's actually a very great question. And also, I think it might be slightly related to this drawing the things. So this is actually this is kind of how to say, the training in the training field of view, the on the job training, right? So we have some on the also before actual the job, we can train the such kind of the activities, something. Then this is sort of the on the view training. We can say like we can also every time in every second we can compare the visual differences between the perspective each other. So for instance, we can imagine that one guy is like a trainee or instructor, then other guy is in parallel eye is like a trainee or a novice person, then doing same task in parallel eye. So we can see every time we can compare each other, and then I think somehow in this from the point of view, we have a lot of very good comparison between the two views because of because of this layout. So I think that's an interesting way of using the parallel, so like providing the parallel situation for training and trainer, and then doing some task, then providing like a clear discrimination, a clear comparison between two. I think.
Actually, I wanted to ask you about what you think about the practical applications actually, and actually learning things in general could be quite useful, especially when you get to see what you are doing at that time, and also see what your trainer is doing, and then perhaps you could actually maybe learn faster as opposed to watching a video on YouTube and then you try it out yourself. There could be some advantages there actually. I think that's great.
And also, I know that another project, this is not my project, but another project is like overlaying two view, first person's overlaying the trainee view and then trainer view. We can impose and providing some more intuitive first person the visualization. I think it's also impossible.
Oh, you mean like an overlapping view, right?
Yes, it's overlapping is the first person view because this layout is kind of split out. But we can also imagine that they will overlapping or integrate. Yeah.
Great. Right. Any questions from anybody? Or
I have one question. Yes. Thank you, Kasahara-san. It was great, interesting presentation. So apparently some of us are working on the research about the physiological sensing, and then basically just try to understanding the human perception from those physiological signals. And then apparently you worked on those perception sharing using those computer vision technology or EMS. And then my question is, do you have any other plan to extend your concept, like jack-in brain, for example, like simulating all the brain signals to share the sensation of the people, or
Yeah, thank you so much. Yeah, I think this is also a very great question of how we can, extend the idea of the superception or engineering sense of self. Because I think the technology itself is very, we can come up the various way of doing that. Because for instance, right now, for instance, this is the general idea of, my face is not so much fancy. But for instance, when we think about like input technology, something like this, so we can imagine that the audio, visual, or something like this. So for instance, like in my previous research, I'm doing a Jack-in head, this 360 video camera. Then that project I only use for the communication. But now we can imagine that we can use that 360 camera for situation, understanding a situation or computer recognition, right? So then it means like we can provide like a augmenting sensory input instead of our visual, but also using the 360 videos. And then another very interesting point is I think the human-computer integration, because when we can capture the sensory signal or the human the state by physiological data or sensory input, then how we can integrate that information and the outcome is very important. So like how we can mediate those computer assistant or computer input and also human outcome or output is another aspect. And then finally, I think the way of the providing action is the very important, the third very interesting area, because in my project, previous project, I'm using EMS to, how to say, make it possible to like integrate action. But we can imagine that exoskeleton or like the human, the actuation system. So I think that the how to say, enabling technology itself can be anything, but important thing, I mean, lastly, I think important thing is the self-attribution. So even we can capture the human, the state or and human the condition, and they provide some like a mediated action. But how we can provide the attribution self is the final the important aspect, I think. So I hope this is answer for your question.
Yeah, actually, I had a relatively similar question to Rio, in the sense that regarding like some of your future works in this field of superception. So a lot of the related works that you shared today is a lot about vision as well as haptics augmentation. Either you change the view or using EMS stimulation. But I think obviously we have three more sensory feedbacks for the humans, right? So there's smell, there's taste, there's audio. Yeah, so there's still like a lot of ways for you to enhance, but at the same time you can also think that things like vision is very dominant, so obviously it makes sense to augment it. Everything else is not as dominant, so it's probably going to be extra challenging. Do you have any feedback about these other kinds of senses, especially like smell and taste, which is quite challenging?
I think that's a good question. I think that's true. So I mainly focus on the visual and haptics or force feedback because they have a very nice time resolution. Because the time resolution, so looking back to my previous project, so many of them is, and I'm looking at the time domain of the sense of self. So I think in terms of that, maybe I think audio is also promising, but I think this is like a, how to say, the trade-off, human sensitivity versus the technological intervention, because for instance, the audio, we have a lot very nice the error detection in audio. So when we, for instance, like when we hear the little noise in the audio, we easy to detect the noise. But in visual, we have a more, how to say, ambiguity, and then actually low sensitivity of the visual. So actually, I think this is the reason of why I'm looking at the visual. But at the same time, the taste or smell is another very ambiguous the area, interesting area, because of the multimodal the integration. So as you know, the taste and the smell is very the influenced by the visual information. Now, I think the combination of those kind of the multimodal sensation might be interesting way to provide such kind of intervention to the sense of self, I think.
Great, thank you. So we have one question by Masai. So he says that he has a question about preemptive actions. Do you think that this system can help to improve reaction time without EMS after trying and learning with EMS? So you use EMS first as sort of a platform to learn it, and then after you remove it, would the effect still last? I think that's what he means by it. Yeah. So right.
I think that's, thank you for the question, and I think this is actually very new topic for me. Right now. Okay, so hope this. Okay, I cannot provide right now, show the material, but actually we are doing exactly this questions. It means like of course, using preemptive action with CMS, we can accelerate. But what if after we disarm this augmentation, and then are we going to be faster or not? Then actually the final answer, not current answer is we found our reaction time is accelerated very, very slightly. But we found that after the long term, it's not long term, but it's like after the 100, I think that was a 200 trial with EMS. We found after that, even after the EMS takeoff, our reaction time gets slightly faster. But the important the findings in this project is we have some very important time spot. It means like, of course, we can provide very, very fast reaction time with EMS, but we don't have agency in it. Then we found if we provide very well-designed time window with EMS, slightly faster, but still we feel sense of agency. Then after that, without EMS, our reaction time gets faster. But if we provide very too early EMS and then without sense of agency, then our reaction time will not get accelerated. So yeah, so the paper is still under review, but actually we found such kind of the observation.
Yeah, I think regarding this time window, so since the question is about if there's a lasting effect, right, from learning with EMS, right. I suppose then the next logical step would be what's the time window to get the best lasting effect? Is it 1 month of training, yes. 2 months of training?
Yes. Yeah. That's actually very interesting. This project let us the interesting phenomenon, the direction, because what is the function of the sense of agency? Because of that, our hypothesis is the sense of agency is kind of the gate for the perceptual learning or some motor learning. Because we have if we feel like this is my action or this is my motion, then we can iterate the motor learning, the procedure or the loop. But if we cannot feel like if you feel this is not my motion, then we should not learn from that action, right? So I think that our hypothesis is that the sense of agency is kind of, how to say, the gate of the learning process. And then if we have a sense of agency, then we can not accelerate. We can foster the learning process. Mm-hmm. But without the sense of agency, we cannot, I think.
Right. Yeah. Yeah, I think so. There's just about 5 minutes left. Maybe just quick one more question if there's anybody. Yeah, so not much of a question, but I suppose I have just one idea, not say idea, but just a reference for you. Because last year when I was at SIGGRAPH Asia Emerging Technologies, there was actually a VR demo where they would let the user. This is related to your what is it? The Malleable Embodiment project. So there was a project last year at SIGGRAPH Asia where they wear a device that changes your center of gravity. So there's like a weight that moves far and back, and by changing the center of gravity, they say that it changes your perception of the inclination of the ground. So by pushing it backwards, you actually feel like you're going up the slope. But it's also a little bit about the sense of weight, body weight and lightness and weight. So I suppose it could be an interesting later work for you to have a look as well. It's just last year's Asia XR demo.
Yeah, that's excellent. And then from this point of view, I have another thing in terms of this project because this is interesting because how we I'm not sure the SIGGRAPH Asia project, but when I doing this project, once I put like the motion tracker bar in their hand, and then we provide anticipated the motion of the full body and also as well as some racket, something like that. And then we provide the same situation. Then in that situation with the virtual racket, the people say it's like a racket gets lighter, not like a body gets lighter. This is actually interesting because even the situation is almost the same, but the attribution of visual error is different. So in with visual virtual racket, they attribute the visual difference into the racket. Then racket feels lighter. They feel racket lighter. But without any external object, there are no option to attribute the visual error. Then they attribute their visual themselves.
Yeah. Well, actually, this is quite close to some of the works I read on peripersonal space. The idea that when you hold an object in your hand, you feel that the object is part of your hand. So maybe there's some correlation there, which is quite interesting.
Yeah, I think so too.
Yeah. Okay, so I think that brings us to the end of this seminar series. Thank you again to Kasahara for sharing his work, as well as all the as well as all the participants who joined us today. So for those who miss this work halfway, or those who join late, or those who want to spread the word, just remember that this video is recorded and will be up on our website. So thank you again, and I will be stopping the recording.